In this lesson, we're going to learn how we can add strands to our particles to give them a nice tail. So here's where we left off, and you can open up 14 random value end. And so now let's come in and add a strand to our particles. So whenever I'm working, let's type in strand to see what kind of strand nodes we have. So we can emit strands, but we want them to be connected to our particles, so we probably don't want that. Let's scroll down. Can create strands, and this might be what we're looking for, so let's just drag this in here and think about it. Let's see if there's anything else that could be creating strands. Well, it looks like the create strands is what we're looking for. So as you can see, the create strands is currently in an error state because it needs to be connected into some sort of execute. Now you'll notice that even though this is an execute port, it's called something else. It's called execute on emit. So what that means is this node wants to be connected into an emitter. So we can see on our emit from null node down here at the very bottom we have an execute on emit 1. Now this is important to connect into the execute on emit and not the ICE tree, because this execute on emit is only calculated or only done once per particle emission. Now if we did this in a different way, we would have to reevaluate the strands on every single frame and recreate them. By plugging things into the execute on emit, we can have them just take effect only when a particle is emitted. So let's plug execute on emit into our emit on, or execute on emit 1, and now let's play this back and take a look. So right now we can see that the strands are connecting the particles, but for some reason they're staying in the center of our beaker here. So if we take a render of this, we're going to see a rather strange image. So the center of our particle cloud here has all of the strands inside of it, as we can see with this dark ambient occlusion. So if we play this back and stop it immediately and take a preview render, we can see that the strands are there, but they're not moving with the particles. So whenever we're working with strands, we always need to create at least two different nodes. The first being this create strands node and plugging that into the particle emitter that we want to have strands emitted from. The next is this constrain strand length. Otherwise, the strands will not care about how long they are and will get very strange results, as we can see here in our viewport. So let's drag in our constrained strand length. Let's put it near our ICE tree. So the constrained strand length is very similar to the simulate particles. It's just a simple execute. Now, earlier we mentioned that we only want to, or that the simulate particles almost always needs to be the last connection inside of our ICE tree, because we want to move the particles after we've set all of the data above it. Now there's something that happens with the strands and the simulate particles node that we need to take a look at. So to show this problem, let's take our constrained strand length and let's actually connect it above our simulate particles. So let's just right click, insert port before, and let's add this in. And now if we play this back, we should be able to see that our particles here are dragging along their strands. So let's hold Q and let's drag out a render region to preview this. So I'm not sure if you'll be able to see this, so let's zoom in on this first particle here. So try to get one particle isolated and let's take a look at it and its strand. So we can see the strand has a very nice tail. However, the particle has a little bit of a dip right here. Now you might be thinking that this is inherent inside of the strand. So let's go back up and take a look at the create strands, because there's a lot of different properties in here. Now we can see we have something called a strand size profile, but we have a regular or a very linear curve down. So we shouldn't be seeing this bump right here. So this bump is actually being created because we do not have the simulate particles before the constrained strand length. So what the constrained strand length does is it takes a look at the particle's position and then it moves the rest of the strands to connect up with it. Now, remember, whenever we do a simulate particles, what happens is the particles move. So what happens is we're evaluating the current position of the particle, which is actually not yet updated. So what happens is the constrained strand length looks fine, and then the simulate particles moves the particle away from the strand a little bit. So for this effect to disappear, we need to have our constrained strand length after the simulate particles, because we want the simulate particles to move the particles wherever they need to be, and then, and only then, we need to move the strand to update with the new particle position. So this is one of the things we always have to watch out for whenever we're working in ice, in that the ordering of these ports are very important to the execution of our ice tree. So now that we've made that change, let's play back again and take a look at the updated particle. Here we are. And now we can see that the strand is connected nicely with the particle. So let's give this strand a little bit more character by having a better or a greater fall off. So let's go back up to our Create Strands. Let's jump into its Properties panel here. And let's take a look at a few things. Right now, the strand length is rather long. So you can see these particles go on for a very long distance. I'd rather have them get cut off a little bit sooner. So let's change the strand length to something like 1. And of course, whenever we change something, we're going to need to replay it to see a change in our viewport. So now here's our new strand length. And of course, this is all dependent on what kind of a look you're going for. You can make them as long or as short as you wish. Now the next thing we can do is modify this strand size profile. Right now we have a very soft curving effect here. What I'd like is for it to taper down much faster. So what we can do is we can modify this curve. So this curve is along the entire strand. How large are these strand particles going to be? Now, if you want to learn more about strands, we do have a dedicated course just to working with strands. So, of course, this lesson is just going to be a brief overview. Well, right now we're saying that at the very beginning of the strand, be the exact same size as the particle, or multiply by a scale of 1. At the end of the strand, multiply by a scale of 0.7. So all we need to do is drag this right-hand key down. And all we need to do is use our select tool here and left click and drag it down. Now we quickly lose sight of it, so we can use our usual camera controls. We can hit A to frame all. We can hold S and then middle click and drag to zoom in and out. And now we can see the entire graph, or as much as we want to see. So let's pull the second one down to about 0.5. And now let's take a look at how that changes our strand profile along the strand. So again, we'll just need to replay it, and now you can see we have a much tighter taper that gives us a slightly more interesting, well, in my opinion, effect. Now, of course, we can really come in here and make a crazy curve by adding a bunch of points, and as you can see with this strand size curve, we have an incredible amount of control over the strand thickness at any point along its length. So let's take a look at these particles now with the strands. And one thing we have to be careful for is when we add strands, we're actually adding quite a few particles. So each strand has 15 new particles in it. So whenever we add a strand, we might want to come into our emitter and possibly pull the rate down a little bit. Because as soon as we add strands, we are going to be getting a lot more particles into our simulation. So what that did to our simulation is it made it have a very blue characteristic, or a very blue tint. So we can, of course, go back into our render tree and decrease the ambient occlusion intensity, but I actually kind of like this effect. So now that we have our strands working and our particles working very nicely, let's come in and learn how to control our particles by using a conditional. So let's say that we want it to slow down and turn black as soon as it enters this second beaker. Well, we'll begin learning how to do that in the next lesson. So in this lesson, we learned how to use the create strands connected into an execute on our emitter. and the constrained strand length as the last node or after the simulate particles to give our particles a nice tail. And again, we do have a dedicated course to strands because there are quite a few interesting effects you can create just using strands. So in the next lesson, we'll learn how we can begin creating some complex particle effects by testing the scene.